Okay, let us discuss the next problem. This problem is again a refraction through curved surface, but we have prism also, we have silvered surface also. So let us first make the diagram. So this is a spherical. Now this surface is silvered. Refractive index is mu, and some light is incident. Are you able to see or not? So some light ray is incident. I will try to not show my fingers. There is nothing interesting there. This point O. Now then this point they are calling R. So a sphere of radius R, so radius is given. This point is, so this is basically radius. So radius of a sphere is R, and mu is 3 by 2. So mu is 3 by 2, that is given in the problem. This means this is a glass. As polished on half of the portion as shown in the figure, a paraxial beam of light is incident along axis OP. So this is the axis OP. So paraxial ray is incident of a hemisphere. Find the position of final image. Find the position of final focus basically this time, because rays are parallel. So wherever the final image, that will be basically focus. So I can find out the same question can be defined something like this. You find out the final image, or you can also say find out the focus. You can be asked to find out the focus, that is same as find final image. That is same as, because final image is nothing but it will on focus, because rays are parallel. So you see, let us see first surface. I can apply mu2 minus mu1 by R is equals to mu2 by V minus mu1 by U. Now this surface has refractive index mu. Let us put 3 by 2. So we will work in terms of 3 by 2. So mu2 is 3 by 2 minus mu1 is 1 by R. Now R is positive or negative. So incident is ray in this direction, and radius is also in this direction, so this is positive. Is equals to mu2 is mu by V, I have to find it out, minus mu1 by infinity, because ray is coming from infinity, so this term is 0. So I can say V is nothing but, this is what? So you just solve and then we'll write. So this is 3 minus 2, so 1 by 2R is equals to mu by V. So from here I will get V is nothing but 2R times mu. Now this is mu2 basically. Mu2 is what? Mu2 is 3 by 2. So this is mu2. I have to plug the value of mu2 here. So V is, are you getting or not? So 2R times mu2, that is 3 by 2. So this will be 3R, and this is positive. So this means image will be formed this side at a distance of 3R. So this distance is 2R, because this is the diameter. So let me pull this one. So this diameter is 2R. So again, as a distance is 3R from here, so 2R plus R. So I will have somewhere here. So this distance is 3R. Up to here, this distance is 3R. Now this means ray is going something like this, and this ray will meet here. So this is image is I1. So this is the refraction through first surface. Now as soon as this light will come here, now this will go through reflection through the mirror, because now I have a mirror. So you see, now effect of this surface is over. So I have taken this surface, so this surface effect is over. Now I will have a simple mirror surface. So I have to take the effect of mirror now. Effect of this surface is gone. So this mirror will see that there is a light that is coming in this direction. And this mirror will not see from where this light is coming, what is the mu. So mu is not depending. So mirror will see a light is coming something like this. So for mirror, now what will be the object distance? So for mirror, now incident is rays in this direction. So for mirror, this is the object distance, that is R. So for mirror will see this object distance is R. Now for mirror I can say, so let me write for this mirror, object distance u, that is r. What is the radius of curvature? Now this time ray is going in this way, so this is the positive, this side will be negative, so this is minus r. So if I apply 1 by u plus 1 by v is equals to 1 by f, 1 by u plus 1 by v is equals to 1 by f, and focus is same as, so you see focus will be in this direction and f is r by 2, so I can apply 1 by u, u is r, plus 1 by v I have to find out, and focus is nothing but radius by 2, but radius itself is negative, so I will have 1 by v is equals to minus 2 by r minus 1 by r, so finally minus 3 by r, so we will have v is equals to minus 3r. So you see, after this surface image will be formed at a distance of minus 3r. This means left side. You see, after this surface, so let us call this is image is I2. So after this surface, we will have a reflection. And this image will be formed at a distance of 3r. So this is my 2r. This image will be formed somewhere here. So 3r is somewhere here. Oh no, this is not 3r. Let me check here. This distance is how much? So v is what? Not 3r. V is r by 3. So this is, you see here. So this is minus 3 by r. So v is minus r by 3. I have done something wrong. So v is minus r by 3. So this means this image will be formed at minus r by 3. This is not r2. I2 will be somewhere r by 3 distance from here. So this is my r. So this will be somewhere here. So I2 will be somewhere here at a distance of r by 3. So this distance is basically r by 3. This means ray will start coming something like this and it will go somewhere here. Are you getting or not? So it will cross the optical axis at I2. Now this ray will further go because these rays are paraxial, so I don't have to use the sine rule. These all rays are basically along the meanwhile, or there is aperture of these rays are very small, so these rays are coming along the horizontal x-axis. So these rays are now up to this surface. Again I have to apply so mu2 minus mu1 by r. So again I have to apply mu2 minus mu1. So to find third image, mu2 by v minus mu1 by u. Now you see, so let us decide. Mu2 is what? So the ray is going in air, so mu2 is 1, and mu is 1 is mu. We will write this is 3 by 2. And r is what? So let us consider r. Now this time ray is incident on this face in this direction. So now this will be positive and this will be negative. So this side is positive. So this side will be positive side, and whatever I measure, this side will be negative side. You see one very important point in this problem. When light ray is incident on this face, I have taken this side as positive. When light ray is incident on this face, I have taken this side as positive. So now you see, if I see my sign convention, for the first part light ray is going something like this, so I have taken positive this, negative this. For the third part, that is the refraction, so first is refraction, second is reflection, and third is again refraction. So if I see the third part, light ray is going this side, I have taken this side as positive, negative this side. So if I measure distances from this point, this side it will be positive, this side will be negative. But in the first part, if I measure distance, this side it will be positive, distance, this side will be negative. So this is a very important point. In same problem, you can change the sign convention. Sign convention depends upon ray. In the same problem, you can always change the sign convention if the ray changes its direction. Are you getting or not? This point is very important point. You don't think that in one problem sign convention remains fixed. It can change its direction. It goes, sign convention goes along with the direction of rays. Wherever rays is going, it is positive. So in this case, now what will be the r? So in this case r will be negative because this side, so r will be minus r. and mu2 is what? 1. V I have to find out, minus u1 is what? So that is mu, and u is what? What is the distance? So this distance is, so I2 is r by 3, so 2r minus r by 3, so that is what? 2r minus r by 3. So let me calculate here. So 2r minus r by 3, that is 4 minus r. So 6 minus r, 5r by 3. Are you getting or not? I am right or not? So this distance is 5r by 3, 6 minus, so this distance is 5r by 3. I can put it here. So this distance, so let me show. So this distance is basically 5r by 3. Are you getting? So this is, things becomes complicated. So you assume this distance is, I cannot write it here. So this is 5r by 3. So if I put this value 5r by 3, now tell me whether this is positive or negative. So you see, the ray in this direction is positive, but this is this side, so this is negative. So this is negative. So now if you solve, mu is equals to what? Mu is equals to 3 by 2. So 1 minus 3 by 2 minus r is equals to 1 by v, and this becomes plus 3 by 2 minus 5r by 3. So you solve this one. What is the value that you are getting? I am betting you have to solve this one. So let me solve. If I want to solve, I can use the next page. So let me solve here. So let me use this page. So let me solve here. So this is minus half, so this is 1 by 2r. This is equals to 1 by v plus, so 3 cancels out. So this means, so minus minus plus, I have already cancelled this one. So this is minus minus plus. So 3 cancels out, so 1 by 10r. Am I right or not? So if I see, so 1 by v is equals to 1 by 2r minus 1 by 10r. So if I take 10 common, so this becomes 10r. So 5 minus 1, so 4 by 10 r. So this is 2 by 5r. So final image V will be 5r by 2. Are you getting? So this is a minus or plus sign. Check the sign. So this is 5r. So this is plus, I think. So you check the sign. This is a plus or minus? I think this is a minus here. So minus up, minus minus plus, minus. So this is plus. You check it. Okay, so if you solve this one, we will come out to be 5r by 2. So check yourself. I think I am right. So the final image will be found at a distance of 5r by 2 from, that is the 2.5r from the point O. So this final image, so let me see here. So final image will be found at a distance of 2.5r this side, because this side is a positive side. So the final image will be found something this side, 2.5r. Are you getting or not? So this is a quite easy problem. Only thing is we can change the sign convention in one problem even. That is an important point. We have to, generally people think that we cannot change the sign convention in one problem. But I have read in some books, not more than, in one book, the D.C. Pandey book, and I have also read one in foreign author book, I don't remember the name. They say that you can change the sign convention in one problem. The sign convention goes along with the ray. That is the important point. We'll discuss the next problem. So you write down